Howdy folks, this is a demo of the Rubik's Cube solver I've created. I initially started this project about 2 or 3 years ago, before it was shelved, but it represents about 3 months worth of work in my free time. It was one of the first projects I wrote while learning Python with a specific focus on scripting for Maya. It's funny to come back to it now with quite a bit more experience and see how differently I'd approach a lot of it. The solver runs live in Maya as opposed to dropping keys into the timeline, which offered more flexibility in development. But as time goes on, I'd like to add an integration to also key the movements into the timeline for animating and rendering purposes. For now, I'm happy to shelve this as a working MVP. Actually, tumbling the cubes in Maya posed an early issue. To solve this, I chose to query all of the cubes by normal, facing in any given direction, and then put them into a temp group to rotate. The function responsible then refreshes the viewport about 20 times per rotation, simulating rotation in real time. This works well enough as a simple solution, but is an opportunity for optimization in the future. All of the algorithms require a world vector nostalgic understanding of the cube. Algorithms need to be run facing one of the 4 lateral faces of the cube, and has to understand how to rotate a section relative to its understanding. One algorithm might require the, quote, machine to be viewing the cube from a -x world space and rotate the left side clockwise, or to view the cube from a +z and rotate the top counterclockwise. This meant that as a developer, I could either reverse engineer the algorithms to all be executed from a single origin, casting them from local to world space, or build a system that could handle the understanding more dexterously. To make development simpler for me, I chose the latter, which, although required more architecture being developed initially, offered me an easier time in the later stages of development when things got complicated enough. The algorithm takes 8 steps to solve a scrambled cube. After the initial MVP of all of them were developed, I quickly realized that testing all the edge cases, especially in the earlier stages, would offer some difficulties. I needed a way to generate a number of variations for each step to test against. To create these, I built a testing system that would save a temp file for each step before it's been executed, run each step in succession, test the result, and if the test failed on any step, save out the file before execution, giving me a testing library created as I went along. The result of this was that anytime a step would fail, I could load up the cube configuration that the step could not correctly solve. In this way, my development style migrated over to quasi-test-driven development. Each step in the testing is also timed and rotations counted. The data is collected in a log file. This offers me insight into what steps need the most optimization. Most steps execute in under 5 seconds with an average of 15 rotations, with the exception of steps 2 and 3, which average 15 seconds and 55 rotations. This is as expected and highlights where optimization can be made when development is continued. The average runtime of execution without testing is around 35 seconds. I've opted to shelf this project with a continuous 100 tests passed, while most of the algorithms have passed hundreds before that. In reflection on this project, now that I've revisited it all this time later, it's interesting to see how evocative the development process has been to the more traditional rigging scripts I've developed. This process required a chain of commands to be executed, each dependent on the success of the previous, and each requiring the dexterity to handle a potential variation of givens. It's good to see the symmetry of development across products and see that this product will go to inform development of my future products.